All right, lesson 8-2, multiplying and dividing rational expressions. Okay, so let's talk about doing some that are just monomials. All right, so the very first one that we're going to look at is 3x to the 7th divided by 2x to the 4th. All right, sorry about that. All right, so you always divide. Okay, we have done these plenty of times. You always divide kind of like the like parts. So in other words, I'm going to divide my coefficients. 3 over 2 does not simplify, okay, or reduce. It's still just 3 over 2. But I know that when I have the same base raised to an exponent divided by the same base raised to an exponent, I subtract those. So it's kind of like I have 4 to take from here and 7 to take from here. I can only take the smallest amount away. So 7 minus 4 would be 3. So this would be x to the 3rd. So I'm just simplifying. All right, let's look at this one. 16 divided by 8 is 2. And then I have 11 and 2. 11 minus 2 would be 9. So this would be 2x to the 9th. All right, so this is just some basic dividing of rational expressions. All right, so let's move into something that's a little more complex. All right, so anytime that we see trinomials, we really want to think about factoring. So as you can see, you have a trinomial on top, and you also have a trinomial on bottom. So let's begin with the one on top. There's nothing in front, so I don't have to worry about this front term. I can go ahead and say that has to be x times x. And if there's a minus in the back, that means I'm going to have 1 plus and 1 minus. And I need two numbers that multiply to make 3 and subtract to make 2. Well, 3 is a prime number, so the only thing that multiplies to make 3 is 3 and 1, and that does subtract to make 2. Since there's a minus in front, the bigger number out of those two numbers will go with the minus. And now I'm going to do the same thing on the bottom. I have a trinomial. I'm going to factor. I have a plus in the back, so that means I have 2 of whatever's in the front. So that would be a plus and a plus. Since I just have an x squared in front, I have x and x. And I need two numbers that multiply to make 4 and add to make 5. That would be 4 and 1. Since they're both pluses, I don't have to worry about where I put the 4 and where I put the 1. Now, I want you to put a little asterisk here, okay? Because in a minute we're going to have to reference this, all right? So here's the deal. I notice that I have two factors, one on top and one on bottom, that are exactly the same, all right? So that means that they cancel, and I am just left with x minus 3 over x plus 4. I don't need the parentheses because nothing is being multiplied to that. Now, this is where the little asterisk comes in. When you have factored, you have to think about things that x cannot be, and that would have to do with your domain. And we always think about, well, in my denominator, I can't have a 0. So what values, when I plug in for x, would give me a 0? Well, if you've already factored, all you have to do is set your factors equal to 0. Just the ones on the bottom. We don't care about the ones on the top. So I have x plus 4 equals 0 and x plus 1 equals 0. So I would subtract the 4. So I've got x equals negative 4 and subtract the 1. X equals negative 1. So these are the two numbers x can't be, because if I plug in a negative 4 plus 4 would give me a 0, and 0 times this would be 0. You can't have a 0 in your denominator. If I plug in negative 1 plus 1 would be 0. 0 times this stuff would be 0. So in my answer, I've simplified that as far as I can go. I will say x cannot be equal to negative 4, and x cannot be equal to negative 1. And you always go with your original denominator, okay? So this before you cancel. Don't just say it can't be negative 4. You have to go with what you had originally. All right, moving on. Number 4. All right, so I look at this and I say, how am I going to simplify this? Well, on top I just have a 3x plus 4. There's no common factor between 3x and 4, so there's nothing I can do with that. So that will stay, but I do notice that on the bottom I have a trinomial. So I'm going to end up factoring that, and in order to do that, to make things a little easier on myself, I'm going to do the illegal move and take the 3 times the 4. So that would give me x squared plus x minus 12. So I'll go ahead and factor that bottom. Since I have the x in front, I'll have x and an x. A minus in back means 1 plus, 1 minus. And I need 2 things that multiply to make 12 and subtract to make 1. That would be 3 and 4. Since there's a plus in front, my bigger number will go with the plus. Now the thing about the illegal move is you can't forget that you did something. You multiplied by 3. So I have to divide both of these by 3. So when I simplify, I apologize, I don't have enough room. 4 over 3 does not reduce, so this 3 is going to have to move in front of the x. So that would give me 3x plus 4. 3 divided by 3 will reduce to 1, so I'll have x minus 1. And then if I notice right here, this is the same as this. So if I take that and I divide it by that, that gives me 1. It doesn't give me 0. Anything divided by itself is 1. So I get 1 over x minus 1. Now I have to think, okay, was there anything that x could not be? So that's where these come in. I have to set both of these factors equal to 0. I don't care where you do it at. I'll do it up here since I ran out of room. So that means I would have to subtract the 4 and then divide by 3. So x cannot be negative 4/3. And then I also have to set the x minus 1 equal to 0. I would have to add 1, so x cannot be 1. All right. Moving on. So I took a look at number 5 here, and I noticed that I have a trinomial on top, and I also have a trinomial on the bottom. So therefore, I need to try and factor. Since there's a number in front, I'll have to do the illegal move. So that would give me x squared plus 7x, and then I would multiply the 6 and the 2 to make 12. On the bottom, I would have to do the same thing, 6 times the 6. So that would give me x squared minus 5x minus 36. So now I'll factor the top. I'm going to have x and x. And I also have, all right, so I have the plus in back, which means 2 of what's in front. So I have a plus and a plus. And 2 things that multiply to make 12 and add to make 7, that would be 4 and 3. But I cannot forget that in the beginning I multiplied by 6. So I will divide by 6. All right, that reduces. 4 over 6 will reduce to 2 over 3. So the 3 will move to the front. 3 over 6 reduces to 1/2. So the 2 will move to the front. Now I need to do the same thing with the bottom. So I will multiply. I've got a minus, which means I'll have a plus and a minus, and an x and an x. So then I have to come up with two numbers that will multiply to make 36 and will subtract to make 5. Okay, that would be 4 and 9. So since there's a minus in front, the 9 will go with the minus and the 4 will go with the plus. And then I have to remember to divide by 6. 4 over 6 will reduce to 2 over 3. The 3 will move to the front. 9 over 6 will reduce to 3 over 2. The 2 will move to the front. All right. And then I notice that I have two factors that are the same. Oh, sorry. I wrote a 3 instead of a 2. The 2 moved to the front. All right, I have two factors that are exactly the same. So those are going to cancel, leaving me with 2x plus 1 over 2x minus 3. Now remember, I always have to think, what can x not be? Well, we can't have a 0 in the denominator. So both of these denominators I would have to set equal to 0. So I have 3x plus 2 equals 0. I would have to subtract 2 and then divide by 3. So x cannot be negative 2/3. And we do the same thing with the 2x minus 3. So I would add the 3 and divide by 2. So x cannot be 3/2. All right, so we're going to do some more examples of that. Okay, number 6, I notice that I have a trinomial on top and a trinomial on bottom, which means I need to try and factor if possible. So I have a minus in back. That means I have a plus and a minus. X squared would be x and x. And I need two numbers that multiply to make 2 and subtract to make 1. That will be a 2 and 1. And since there's a plus in front, 2 will go with the plus and 1 will go with the minus. Same thing on the bottom. I have a trinomial. There is a minus in the back, so that means I'll have a plus and a minus. X squared in front means I have x and x. And two numbers that multiply to make 3 and subtract to make 2 would be 3 and 1. Since there's a plus in front, 3 will go with the plus because it's bigger. And I notice that I have two factors that are the same, one on top, one on bottom, and they cancel. We only cancel from top to bottom. So I am left with x plus 2 over x plus 3, and I have to think, what can x not be? Well, if I set both of these equal to 0, remember just the bottom, I will get negative 3 and positive 1. So x cannot be negative 3 and x cannot be 1. All right, number 7. So I have to look here. I notice that I don't have a trinomial on top, but I do have a common factor between 2x and negative x squared of x. So I'm going to factor out just an x. So that would leave me with 2, and that would leave me with a negative x. Be careful in your signs here. Okay. And I notice on the bottom I have a trinomial, so I'm going to factor that like I normally would. There is a minus in the back, so I have 1 plus and 1 minus. X squared in front means I have x and x. And two numbers that multiply to make 2 and subtract to make 1 are 2 and 1. Since there's a minus in front, the bigger number, which is 2, will go with the minus. And I noticed that I don't have any common factors between the top and the bottom, but I noticed that these two are very similar. The only problem is that 2 is positive here and negative here, and negative x, and this is a positive x. So if the signs were switched, then I would be able to take them out. So with that being said, if I were to factor out a negative with this x, so I would take out a negative, that would make this 2 a negative and this x a positive, which would be x minus 2. And now it matches the denominator. The whole thing is that usually you're going to have something that's going to cancel. So this cancels, leaving me with negative x divided by x plus 1. Now there will be several of you who will try to cancel your x's. You cannot do that unless there is an x between all three of these terms, okay? Or if you had like a whole factor, okay? So now I have to think what x cannot be. Well, I have x plus 1 and x minus 2 on the bottom. So I set them both equal to 0. So I get x equals negative 1. And I get x equals 2. So x cannot be negative 1. And x cannot be 2. Okay, so number 8. On top, I don't have a trinomial, but I do have a common factor between 10 and negative 2x. So I'm going to go ahead and take out a negative 2, and this is why. If I'm expecting it to match the bottom, this x is going to at some point have to become positive, okay? Now, it doesn't always match. You don't always have common factors between the top and the bottom, but in these cases, most of them you do. That's the whole point of the lesson. So I'm going to take out a negative 2. So that leaves me with 5. Oops, excuse me. 10 divided by negative 2 is negative 5. And negative 2x divided by negative 2 would give me a positive x. So this is the same thing, only it's written backwards. So just so you can see it, I'm going to put the x in front and the minus 5 behind that. And then I notice that I have matching factors. So I have negative 2. And I have to remember that I did have something in the denominator. I had an x minus 5. So if I set that equal to 0, I would have to add 5. So originally x could not be 5. All right, number 9. Number 9, I don't have a trinomial on top, but I do have two terms that have a common factor of x. And normally, if I have a factor down here, the x will not be negative. So I'm going to take out a negative x. So that's going to leave me with a positive x. And then 3x divided by negative x would be negative 3. On the bottom, I do have a trinomial. So there's a number in front, so we need to do the illegal move just to make things easier on ourselves. So that would give us 2 times 3, which is 6. So there's a plus and back, which means you have 2 of what's in front. You have an x squared, so that would be x and x. And 2 numbers that multiply to make 6 and add to make 7 would be 6 and 1. Since you have 2 minus signs, it doesn't matter where the 6 goes and where the 1 goes. But then I have to remember that I multiplied by 2, so I need to divide by 2. Six divided by 2 is 3. And then this 2 needs to move to the front. So that would give me 2x minus 1. So now if you're noticing, you have common factor between the numerator and the denominator, but x minus 3. So those will cancel out, leaving you with negative x over 2x minus 1. And you have to think about what x cannot be. Well, I would have to set the x minus 3 equal to 0, and the 2x minus 1 equal to 0. So x cannot be 3. And I would have to add 1 and then divide by 2. So x cannot be 1/2. Okay, so now let's talk about multiplying rational expressions. This is a part that can get a little bit tricky if you're not, paying attention. Okay. When you are multiplying things, notice there are no plus or minus signs. So every single thing is a factor. Okay. I like it when there's no plus or minus signs. Those are nice. So these two don't have any plus or minus signs. So I can cancel this direction. I can cancel diagonally because these are being multiplied. Or I can multiply across and then cancel. You get some big numbers if you do that, but it also kind of eliminates some confusion sometimes. So I kind of like to go across, but then I kind of don't like to go across. I just kind of do it different all the time. So it's totally up to you. But this is how I'm going to approach this. I see that I have 2 and 8. Tell you what, let's just go ahead and multiply across. I think that would be easier for y'all. So this was 2 times 15, which would give me 30. X to the 4th times x to the 2nd. Remember, you just add those, so that would be x to the 6th. And then I have a y to the 5th, but I don't have a y over here, so this would just be y to the 5th. Then I've got 3 times 8. That would be 24. X squared times x to the 3rd would be x to the 5th. Remember, you just add them. And I don't have a y here, but I do have a y squared here. All right. So now that I've got that, I just need to reduce 30 over 24. That reduces to 5 over 4. I have x to the 6th divided by x to the 5th. Remember, when you're dividing, you subtract. So I had 6 on top, 5 on bottom. 6 minus 5 is 1. So that would just be x to the 1st. And then I have 5 y's on top and 2 y's on bottom. 5 minus 2 would give me a y to the 3rd. All right? You can also think of it like this. There are 5 to take from here. That would leave 1 here. There are 2 to take. That would leave 3. All right? And that's my answer. So let's take a look at number 11. If I multiply straight across, I've got 1 times 20 would be 20. And then x to the 1st times x to the 7th would be x to the 8th. On the bottom, 15 times 2 is 30, times 1 is 30. And then I have x to the 1st times x to the 4th, which is x to the 5th. And then I reduce. 20 over 30 will reduce to 2 over 3. And then I have 5 x's here and 8 here. 8 minus 5 is 3. Again, you can think of that, okay, I have 5 to take, so I'll take 5 from both. All of these go away. Oops, take 5, which would leave you with 3. And then that's my answer. All right, so let's make them a little bit different. Now I've got plus and minus signs. So you have to be able to cancel out an entire factor. Okay? So this is what you do. Every time you have something, you want to look and say, okay, is there any way I can factor this? Be it a common factor, greatest common factor? Is it a trinomial? Is it difference of 2 squares? So on and so forth. This is just x plus 2. I cannot factor x plus 2. There's no common factor. It's not the difference of 2 squares. All right, on the bottom, I have 3x plus 12. It's not a trinomial. It's not a difference of anything. But I do notice that 3x and 12 have a common factor of 3. So if I factor out a 3, 3x divided by 3 is x, and 12 divided by 3 is 4 times. I can't do anything with x plus 4. It's just x plus 4. There's no common factor. It's not the difference of two squares. X squared minus 4. That's a perfect square with a minus sign. So remember that factors. Give me a plus and a minus, an x and an x, and then the square root of 4 is 2. So now I'm looking to see if I have common factors on top and bottom. So I notice that I have an x plus 2 and an x plus 2. So those cancel, leaving me with 1 up here. And then I notice that I have, an x plus 4 and an x plus 4. So that leaves me with a 1 on top. Now I'm going to multiply them. 1 times 1 is 1. And then I have 3 times x minus 2. So I would need to distribute. 3 times x is 3x. And 3 times negative 2 is negative 6. And I'm not worrying about what x cannot be. Okay, I'm not stating the domain. I'm just going to leave it as it is. All right, so take a look at 13. I look at 10x minus 40, and I notice that I have a common factor between those two terms. So I'm going to factor out a 10. That would leave me with x minus 4. On the bottom, I have a trinomial, so I need to try to factor that. There's a plus and back. That means 2 of what's in the front. I have x and x. And then two things that multiply to make 8 and add to make 6 would be 4 and 2. Since I have two minus signs, 4 and 2 will work. X plus 3, I don't have a common factor there, so I leave it as x plus 3. 5x plus 15. 5x and 15 have a common factor of 5, so I'll factor out a 5, leaving me with x plus 3. So now I'm looking for common factors. Well, I notice that I have an x minus 4 on top and an x minus 4 on bottom. So that just leaves me with 10 on top and x minus 2 on bottom times. I notice I have x plus 3 and x plus 3. That leaves me with a 1 on top. So I have 1 over 5. But then I also notice that diagonally, I can reduce 10 over 5. So 10 divided by 5, 5 goes into 5 one time. 5 goes into 10 two times. And then this is just 1. So when we multiply by 1, this just kind of goes away. So you have 2 over x minus 2. All right, number 14. X minus 3, I have no common factor to factor out there. 4x plus 20 has a common factor of 4, so I'll factor out a 4. That leaves me with x plus 5. X plus 5 is just x plus 5. And then I have x squared minus 9. That's the difference of two squares. I have a plus and a minus, x and x. And then the square root of 9 is 3. So I notice I have an x minus 3 on top and x minus 3 on bottom. So that leaves me with a 1. X plus 5 on top, x plus 5 on bottom. That leaves me with 1. 1 times 1 is 1. And on bottom I have 4 times x plus 3, so I distribute. That would give me 4x plus 12. All right, so let's talk about dividing rational expressions. I know you guys have heard of keep, change, flip, I'm assuming. All right, really it's the same thing as multiplying by the reciprocal, and I would rather use that term. But it refers to when you are dividing with a fraction, okay? So instead of keeping it this way, you keep the first fraction. You change division to multiplication, and you're going to flip the second one. So 12y squared will be on top, and the x to the fourth y will be on the bottom. All right, so essentially you're just multiplying by the reciprocal, okay? So then you can multiply across or cancel right now, however you want to do it. I'll just multiply across. 1 times 12 is 12. Then I have an x squared, but no x. And then I have a y squared. On the bottom, 4 times 1 is 4. And then I don't have any variables, so I just tack these on to the end. And then I divide. 12 divided by 4 is 3. I have 2 x's on top and 4 on bottom, so this one's going to go away, and the ones on bottom will decrease by 2. So that leaves me with an x to the second on the bottom. And then I have 2 on top and 1 on bottom for my y, so 1 will go away, leaving me with just 1 on top. And I'm done with that right there. Okay? So that is the only thing I'm going to show you on that, because once you keep, change, flip, you've pretty much just done a multiplication problem, which we did several of those. So now let's talk about solving rational equations. Now we've kind of done this already, so this really shouldn't be anything new to you. But the first thing you always want to try to do is see if you can factor what you have. So in other words, you have a difference of 2 squares here. So that means it splits into 2 with a plus and minus, and xx, and then the square root of 9 is 3. The reason that's helpful is because now you can cancel these factors. So I have x plus 3 equals 7. So now all I have to do is subtract 3, and x equals 4. Now here's the one thing you have to think about. In the beginning, right here, that denominator, I need to think about what x cannot be. So if I set that equal to 0, x cannot be 3. So in the end, if I get 3, that's no solution. All right, so 4. 4 does not pose a problem. That does not give me a 0 in my denominator, so 4 is fine. Okay, the answer is just 4. Let's look at this one. I noticed that on top I have a trinomial, so I'm going to go ahead and factor that. Minus and back means 1 plus and 1 minus. I've got an x and an x for the x squared. And what multiplies make 12 and subtracts make 1 would be 4 and 3. There's a plus up front, so the bigger number, 4, would go with the plus. And the nice thing is that now that gives me a common factor on top and bottom that can cancel. So now I just have x minus 3 equals negative 7. To solve for x, I add 3. So I get x equals negative 4. So I need to think about that answer. If I were to plug negative 4 in right here, negative 4 plus 4 would give me a 0. And I can't have a 0 in my denominator. So since that is the only answer I have, it's extraneous, so we have to say no solution. So if the number that you get in an answer is going to give you a 0 in the denominator, it's no solution. And sometimes it's a good idea just to figure out what it's going to be in the beginning. Go ahead and just set the denominator equal to 0. Okay? And this last one, I have a trinomial on top, so I'm going to factor that. I have a minus sign in the back, so a plus and a minus, an x and an x. And 2 numbers that multiply to make 10 and subtract to make 3. That would be 5 and 2. So since there's a plus in front, 5 will go with the plus and 2 will go with the minus. And that helps me out because these 2 will cancel. And I have x plus 5 equals 7. I'll subtract the 5. So I get x equals 2. So I have to think about that. If I plug 2 in right here in the denominator, 2 minus 2 would give me a 0. We cannot have a 0 in the denominator, so that is an extraneous solution. So we do not have a solution.